talked about the distributive property, and that's how we ended our week. So that's how we're going to start this week. So our fair game review for this week, we're going to do 2 examples, okay? We're going to start with 7 times the quantity, 3x plus 2, okay? And we are going to do 4 times the quantity, 5x plus 3. Now feel free to pause and work these on your own, okay? All right, so we remember that if we are going to apply the distributive property, whenever you see a number outside of a parentheses like this, it means to multiply. It means I want 7 groups of 3x and 2. Okay, so our trick was to multiply the number on the outside by everything on the inside, and I always say give one to Chloe, give one to Emma, helps me remember, okay? So we have 7 times 3x, because remember this number means to multiply, and okay, we have 7 times 2. Okay, so all I'm doing is getting rid of the parentheses by doing the actual operation. When I multiply these together, I get 21, because 7 times 3 is 21x plus 14. Okay, and notice within 21 and 14, do you see the 7? Because 7 is a factor of 21 and 7 is a factor of 14. And that's always going to be true. Okay. For this one, we're going to multiply 4 times 5x. So give one to Chloe. 4 times 3, give one to Emma. So we're going to do 4 times 5x and 4 times 3. Let's go ahead and combine here. 4 times 5x is 20x plus 4 times 3 is 12. Okay, and that is my final answer there. Now notice you see the 4 in the 20x and you see the 4 in the 12, because 4 is a factor of 20x and 4 is a factor of 12. Okay, all right, well, we are going to use that with our learning target today. So our learning target today is we will factor, and I just said that word factor a couple times up here. Okay, we will factor algebraic expressions using the GCF. Okay, now if you forgot what GCF was, greatest, here's that G, common.
Mommy?
Hold on one second. Okay, sorry about that. Factor. Okay, greatest common factor. So we're going to factor algebraic expressions using the GCF. Now, here's something very cool, and I'm going to write this in red so we know it's different. Factoring is the opposite or reverse of distributive property. Okay, that means instead of starting with an expression that has a parentheses and removing it, we're going to start with the expression that doesn't have a parentheses, and we're going to stick it in there using the greatest common factor. Okay? All right. So here's your definition of factoring. Definition of factoring is when you rewrite the sum of 2 or more numbers as a product product of the GCF of those two numbers and the sum of what is left. Okay, go ahead and shake out your hands if you need to, because that was quite a bit. Okay, so we're going to rewrite the sum. Okay, here's the sum of two or more numbers as a product. Look, if you go back this way, all of a sudden we've turned it into a product of the GCF. Okay, 7 is the greatest common factor of 21 and 14, and the sum of what's left once it's factored out. So we are going to actually put this in action. Okay, so I'm going to push this up a little bit. All right, so I'm going to show you a couple of examples of exactly what this looks like. Okay, and we are actually going to start with the two examples that we did in our fair game review. So we started with 21x. Notice I gave myself some room over here, plus 14, which means we're looking for, okay, the common factors of 21 and 14, which means we can list out 21 and 14 and list all of the factor pairs. This is one strategy. So I know that 1 times 21 is a factor pair. 2 does not divide 21 because it's odd, but I know 3 and 7 are the other factor pairs. For 14, I know 1 and 14 is a factor pair. 14 is even, so I know 2 times 7 is a factor pair, and there's nothing else in between. And notice that I have 7. Okay, so that means I'm going to divide both of these numbers by 7. Okay, and I'm going to see what happens. So I'm going to put 7 on the outside, okay, and then 7 out of 21 is 3x, and 14 divided, oops, I'm going to put that there, 14 divided by 7 is 2, okay. This is one way to do this math, and notice that we got the exact same thing that we started up here. We just reversed it. I want to show you another way, which is kind of a shortcut. Math is just a shortcut, right? And so what I'm going to do is I'm going to show you something very cool called the decomposing box. Okay, let's go back to this example. Okay, and we can write over here, decomposing box. You can pick either way that you want to do this, but I'm going to do this a whole bunch of ways because I think it makes it easier. So again, we're going to start with 21x plus 14. Okay, what I'm going to do is I'm going to write an upside down division box. Okay, upside down division box. What I'm going to do is I'm going to say what number goes into 21 and 14. And I'm going to start thinking this in my brain using mental math, because you guys like to use mental math. And I know that 7 goes into both 21 and 14. So I'm going to pull the 7 out, okay? And it's like dividing, because 21 divided by 7 is 3x. Drop down that plus sign. 14 divided by 7 is 2. Again, the same thing I have here, okay? So now what I'm going to do is I'm going to rewrite this as a product of the greatest common factor and the sum of what's left. So that means I put the 7 on the outside of the parentheses because this is what I pulled out. This is the greatest common factor of these two numbers. And then I'm going to write the sum of what's left, 3x plus 2. Okay, so the greatest common factor goes on the outside. The sum of what's left goes on the inside. Let's try this again. Okay, let me get you a little bit more here. All right, let's try this with our other example from the top. Okay. So we had 20x plus 12. Now what's amazing about the decomposing box is, and the reason why I like to use the decomposing box is because you don't have to find the greatest common factor first. How many of you noticed that 20 and 12 are both even numbers? So we can divide by 2. I always think about what numbers can go in 2, 3, 5. Those are my go-to numbers, 2, 3, 5. And I know that 2 goes into 20 and 12. And when I do that, half of 20x is 10x, and half of 12 is 6. But notice that 10 and 6 are both still even, so they can be divided by 2 again. So I'm going to build another box, okay? And I'm going to say, wait a minute, 10 and 6 can both be divided by 2. Half of 10x is 5x plus 6 divided by 2 is 3. Now look, 5 and 3 are mutually prime. So I know that I'm done. So this is what goes in the parentheses. But now we've got two 2's up here. So this is really important. What we have to do with these 2's is we are just going to multiply them. So I'm going to do 2 times 2 is 4, because 2 times 2 is 4 is the greatest common factor. So I'm going to have 4, okay, that's the greatest common factor, 2 times 2. And inside the parentheses, I have the sum of what's left, 5x plus 3. Okay. So this is called the decomposing box because I'm going to break this apart step by step. This is also a strategy that you can use throughout your math career. You can do this in algebra. You can do this with quadratics or other polynomials. Okay, so let's go ahead and let's do a few more examples using the decomposing box. All right. A few more examples. So we're going to start with, we did those ones, 35m plus 7. Okay, 35m plus 7, and I want to factor. Okay, I want to factor 35m plus 7 because I want to know how many groups, right, I have in here. And what I'm going to do is I'm going to start by doing my decomposing box. This is going to be an upside down division, so it means to divide. And I'm thinking in my brain a number that goes into 35 and 7. Okay, and I start with 2, 3, 5. I know that 2, 3, 5. 2 doesn't go into 35 or 7. 3 doesn't go into 35 or 7. But 5 goes into 35, but not 7. But I noticed when I divided 35 by 5, I got 7, which means that 7 goes into both of these. So I'm going to divide out a 7. When I do that, 35 divided by 7 is 5m, don't forget the variable, plus 7 divided by 7 is 1. It is so important that we have this one. We cannot lose this one, okay? So 5 and 1 are mutually prime, so I can put these in parentheses and say, yep, I have this factored. All I'm going to do is drop this 7 down in front of it because I have 7 groups of 5m plus 1. Look, 7, watch what happens when I write this. 7 groups of 5m plus 1. Remember how I said these are inverse operations or opposite operations? 7 times 5m is 35m. 7 times 1 is 7. So I can check my work this way too. Okay, so 7 groups of 5m plus 1 is 35m plus 7. Let's do another example. We are going to do 30a plus 42. Okay, again, in a decomposing box. And I'm looking for numbers that can go into both 30 and 42. And again, the decomposing box, we want to break it apart piece by piece by piece. And I noticed that both 30 and 42 are even, so I'm going to divide by 2. Okay? I know that 30 divided by 2 is 15a, don't forget that, and half of 42 is 21. I also noticed that 15 and 21 were not mutually prime. Does anybody know what number goes into both 15 and 21? Well, if I check 2, 3, 5, I know 2 does not divide either of these because they're not even. 3 goes into 15 and 3 goes into 21, so I know I can divide both of these by 3. Okay, 15 divided by 3 is 5a, and 21 divided by 3 is 7. Look, 5 and 7 are mutually prime, so I can put the parentheses. Okay, so 2 and 3 alone are not the greatest common factor here, but when I multiply them, okay, when I multiply 2 times 3, I do get that number, okay? So 2 times 3 is 6. So that means the greatest common factor here is 6, all right? And the sum of what's left is 5a plus 7. Okay, now some of you might have noticed that 6 goes into both of these numbers right away, and you can pull that number out if you want to, but it's really nice to start with prime numbers over here first. Okay, let's do another example. I have 20x plus 12. So we're going to start with the decomposing box. I'm going to break it apart piece by piece, okay? Because what I want to do is I want to factor the greatest common factor out of 20 and 12. So I'm going to start with my prime numbers, 2, 3, 5. Well, I noticed that 20 and 12 are both even, so I'm going to pull out a 2. Okay, when I say I'm pulling out a 2, it means I'm factoring, okay? Because what I'm doing is I'm taking out things that they have in common. Half of 20x, or 20x divided by 2, would be 10x. Because if I have two groups of 10x, I have 20x. Same thing here, I get 6, because 12 divided by 2 is 6, or two groups of 6 is 12. All right, these guys are not mutually prime. They still have another common factor, okay, and that common factor would be 2. Okay, 10x divided by 2 is 5x, and 6 divided by 2 is 3. 5 and 3 are mutually prime. They don't have any other common factors, so I can put the parentheses around. Okay, and remember, on the outside, and one thing that some people like to do is draw a G out here, because this is the greatest common factor, if you want to. And I know I have to multiply 2 times 2. 2 times 2 is 4, so that means when I rewrite this, I have 4 groups of 5x plus 3. 4 times 5x is 20x, which is what I started with, and 4 times 3 is 12, which is what I started with. Okay, let's do another example. This one just takes practice to become permanent. And I'm going to add a little bit of challenge here. We're going to do this. We're going to do 48c plus 16d. I have two variables, but that's okay, because what we're doing is we're factoring the numbers, we're factoring the coefficients, okay, not the variables. You can, but we won't be doing that this year. You will do that next year. Okay. So when I want to factor 48 and 16 using a decomposing box, how we've done it in the past, it's look and see what they have in common and use those first prime numbers, 2, 3, 5. I notice that both of these numbers are even, so I'm going to divide by 2. 48 divided by 2, 24c. Okay, because two groups of 24c would be 48c. 16d divided by 2 is 8d. Okay, half of 16d. 24 and 8 are not mutually prime, so we have to keep going. They have another common factor. And it's, look, 24 and 8 are even again, so I'm going to do 2. 24c divided by 2, well now sorry friends, I get 12c, and half of that would be 4d. Goodness, still not mutually prime. They're both even. I have to keep chipping away at this until there are no other common factors. So I'm going to take out another 2 because 12 and 4 are even. And I'm going to get 12 divided by 2 is 6c. and 4 divided by 2, okay, is 2D. Still not prime. 6 and 2, again, are still even. So I can divide by 2. 2 divides 6C to get 3C, and this gets 1D. Now you can just leave this as D. So I know that since 3 and 1 are mutually prime, I'm going to put the parentheses in it. And I know that's the parentheses that make my new number, right? But in here, remember how we put that big G around all of this stuff? When we do this, it means we have to multiply. So that means I have to do 2 times 2 times 2 times 2. Okay? Now, 2 times 2 is 4. Okay? Times 2 is 8. Times 2 is 16. Now that was a super shortcut that I'm not sure I love a whole bunch, but let's try that again. So I'm going to do 2 times 2 times 2 times 2. 2 times 2 is 4 times 2 times 2. 4 times 2 is 8 times 2 is 16. Okay, so there's a couple different ways to look at that math. So that means the greatest common factor of this guy here is 16 groups of 3C plus, and I'm going to drop the 1 here because remember 1 is the multiplicative identity and I don't need it. So that's what you get. And look, C times 16 times 3C is actually 48C, and 16 times D is 16D. All right. Here we go. We are going to do (15p) minus 20w. Okay? And we're not going to worry about the subtraction because we noticed the subtraction just drops down, drops down, drops down. Okay? We're going to leave this as subtraction. And I'm going to draw my decomposing box. Okay. And I'm going to look for common factors between 15 and 20. And I noticed use 2, 3, or 5. And look, both 15 and 20 are divisible by 5. So we're going to pull out that 5. 15p divided by 5, 3p. For now, let's just drop down our subtraction sign. And 5 goes into 20w for w times. Okay? And that's it. We know that 3 and 4 are mutually prime. So now all we have to do is just say, hey, my greatest common factor is 5. Give me 1 second, friends. Sorry about that. So we know that the greatest common factor is 5, and the sum of what's left is 3p minus 4w. Okay, so 5 times 3p is 15p. 5 times 4w is 20w. And this is how you factor using the greatest common factor. 5 groups of 3p minus 4w is 15p minus 20w. All right, I'm going to give you a couple other examples to work on your own. Okay, first example. How about 16m plus, make sure I didn't do this one already. How about 12? And your second example that I'd like you to try on your own is, how about we'll do 36r plus 24. All right. That is everything. Have a wonderful day.